everyone, we're going to find the area bounded by the given curves y equals x to the power of n, y to the power of n equals x, and our x is greater than or equal to 0. What we can notice here is basically these are just inverses of each other, where they just switch the x and the y's. So if we graph this one, this is just y equals x to some power, it's going to look like this. Comes up like this. Maybe I want to make this a little bigger because it's going to be hard to see. So I'm going to make this a little bigger here. And it comes through here. Of course, we want x is greater than or equal to 0. So we want this 0 and go this way. This is your x. All right, and then the inverse is just going to open up to the right here. So this would be going up here like this, or, down here. But the shaded region is going to be right in here. Now, since they're inverses of each other, we could say, well, they reflect over y equals x. So that means I can draw this line here, y equals x. So this is y equals x. This lower bound here is y equals x to the power of n. And what I can do is you can kind of, we already see one intersection point is at 0, 0. We can also surmise, if you want, that this intersection point is 1, 1. But the way to do that algebraically is to know that we have y equals x to the power of n, and we also know that it's going to intersect here at y equals x. So if you set these equal to each other, we're going to have x to the power of n equals x, or you could say x to the power of n minus x equals, and we want to set this to 0, which equals x times x to the power of n minus 1 minus 1. All right, so that would give you your x equals 0 as an intersection point, and for this piece, we would get x equals 1. All right, so that's that part. Now, to set up our integral, since it's symmetric to this this part here, to the line y equals x, we're going to use y equals x as our upper bound. So we're going to write this as the integral from 0 to 1, and we're just going to take the area of this part here and multiply it by 2. All right, so the upper bound is going to be your y equals x. You write x minus. And then your lower bound is this x to the power of n. So you're going to subtract x to the power of n and then dx. All right, so this is going to give you 2 when you integrate this. This is going to be 1/2 x squared minus, and then for this piece you're going to add 1 and then divide by n minus 1, or n plus 1. And we're evaluating it from 0 to 1. But basically we just have to do the 1 part because the 0 is going to make everything 0 out. So you're basically going to get 2 times 1/2 minus 1 divided by n plus 1. All right. Once you get that, you can leave your answer that way, or we can distribute that 2 and get 1 minus 2 divided by n plus 1. And that's it. Thank you. Have a nice day. Bye-bye.